Hello, my dear students. Once again, welcome back to your online class. So, today we'll be learning a chapter, the three-dimensional geometry, that comes under the section B of your mathematics syllabus. And if you turn out your textbook that you have in your house all along with you, so it is the chapter number 23. Okay, so now in the previous video in the vector as well, I had briefly discussed about the three-dimensional geometry. Here we'll be going in details about the three-dimensional geometry. Okay, so usually in the three-dimensional geometry, we have the three axes which are mutually perpendicular to one another. The one being the x, the other is the y, and the last one being the z axis. Okay, so now to define or specify any point in three-dimensional geometry, we require the three coordinates. Okay, one belonging to x, another to the y, and the last one belonging to the z. Suppose here I have a point P. This point P simply can be represented by x, comma, y, comma, and z, where x is the x coordinate, y is the y coordinate, and z is the z coordinate. Apart from specifying a point, here we will be talking about the plane as well. So if you see here, we have the three planes. Okay, now what is plane? If you want to see, you can again look at the corner of a room. So we have three planes, one being a wall. Okay, along this way, the forward, and another being the ceiling. So there are three planes in a three-dimensional geometry. So the namely it is xy plane, yz plane, and then zx plane. So each of these plane can be simply represented in the form of equation. Like if you want to represent this xy plane, okay, so xy plane. So you see that every point in this plane, the coordinate of z will be equals to 0. So if it is z is equals to 0, then it represents the xy plane. Coming to the second plane, that is y z plane. Okay, so that is y z plane. So in this plane, at every point, the coordinate of x is 0. So if x is equals to 0, then that represents the yz plane. And finally, we have one more plane is this plane, that is the xz plane. Okay, so xz plane, if you see here, at every point in this plane, here the y coordinate will be equals to 0. So y is equals to 0. So these three equations, a very simple equation, it represents the three plane, being xy plane, the yz plane, and the xz plane respectively. So now keeping this in mind, we can also easily define or represent any point in that lies in any of these axes. Suppose if you have any point here lying in a x-axis, so the coordinate of this point is simply the x, 0 and 0. And if any point lies on a y-axis, it can be represented by 0, y and 0. Okay, it means that here the x coordinate is 0 and the z coordinate is also 0. And the last one, if any point lies on the z axis, the coordinate can be represented by 0, 0 and z. Okay, so this is how we represent any point in the three-dimensional geometry, or in the space, better we say. Now there are some of the important terms like the directional cosine, and the directional ratio. Okay, so we'll try to understand how to find the directional cosine and the directional ratio. Some for you, like by solving some of the problems given in your book. Now, a brief discussion about the directional cosine. It is nothing much like if I have any point P here, and if I join the origin to this point. Okay, so we know that this line will make angle with all of these, sudden angle with all of these three axes. Okay, like with the x-axis, if it makes alpha, with the y, if it is beta, and if with the z, if it is gamma. Then directional cosine is defined as like the directional cosine of x-axis. Okay, simply can be represented by L. With the y, it can be represented as m, and with the z-axis, it can be represented as n. So directional cosine is the cosine of the angle. It is the cos of, like if with the x-axis, it is alpha. Okay, cos of the angle that makes that the given line makes with the respective axis. So m here it will be cos of beta, and n it will be cos of gamma. Okay, so using like taking few of the examples, we'll try to find how to find the directional cosine and a directional ratio of a given point or a line of a line segment which is described by a 2 point. So we'll solve one of such kind of questions. So here in the board, I have written one question in the short form. Like the question is like find the directional ratio and the directional cosine of the line joining the 2 points, namely P6, comma minus 7, comma minus 1 and 2, comma minus 3, comma minus 1. Okay. So we know that if this is the 2 point, like this is P and this one is Q. Okay. So I have a line represented by 6, minus 7 and minus 1, and here I have 2, minus 3 and 1. So you have to find the directional ratio and as well as the directional cosine of the line joining that 2 point. So how to do that? So we'll do like let the direction. So first we'll find the directional ratio, and after we obtain the directional ratio, it will be easier to find the directional cosine. So let A, B and C be the directional ratio. Okay, where A is the directional ratio of the x coordinate, B is for the y, and C is for the z. So how do you find? Very simple. So A will be equals to x2 minus x1, oh sorry, x1, B will be equals to y2 minus y1, and C will be equals to z2 minus z1. So simply here, if I take this one as x2 and this one as x1, so it will be 2 minus 6, this is going to be minus 3 plus 7, and the last one for z it is 1 plus 1. So this gives me minus 4, this will give me this will give me 4. Is it 4? Yes, 7 minus 3 it is 4. And this will give me 2. Okay, so these are the directional ratios. Now using the directional ratios, it is very easy to find the directional ratio. So the directional ratio for the x, it is L. So L will simply be equals to, it is A divided by under root of A square plus B square plus C square. Okay, so this will give me, how much is A? A there I have minus 4. So it is minus 4 divided by under root of, it will be minus 4 square plus 4 square plus 2 square. So this will give me minus 4 divided by under root of 4 for the 16, 16 plus 16 is 32, 32 plus 4 it is 36. Okay, so this will be minus 4 divided by under root of 36, it is 6. Okay, so this will give me minus 2 by 3. So that is how we find the directional cosine. So similarly, m will be equals to, simply it is b. B it is 4 divided by, so finally I get this one 6. So it will be 2 by 3. And finally n will be equals to, and here I have 2. So 2 divided by, so 2 divided by I have it is 6. Okay, so this will be 1 by 3. So these are the three directional cosine. So this is how we find the directional cosine and the directional ratio.